Hi, welcome back to my channel. I'm Anando, and today we're going to be doing questions from chapter 1.5, projectile motion. So let's start by doing question number 1. I'm not going to do all the questions, but I'm going to do a few of them to help you guys get started with this. So question number 1. A rock is kicked horizontally off a cliff and moves 8.3 meters horizontally while falling 1.5 meters vertically. Calculate the rock's initial speed. So if I were to draw a diagram, let's say this is where the rock is being kicked off from, so 1.5 meters, and it's being kicked horizontally. That means if it's kicked horizontally, it doesn't have a vertical component of velocity because it's being kicked this way. So if you're kicking it this way, and you're not kicking it up or down, that means there's zero vertical velocity in the y direction, initially at least. So vertical velocity in the y direction is going to be 0. You know that the y component displacement is 1.5 meters, 1.5 meters up, or negative 1.5 meters down. And the displacement in the x direction is just 8.3 meters to the right. So I'm going to start by calculating the time it takes for this rock to hit the ground. So I can use the equation displacement equals VIY times time plus half acceleration times time squared. I know that the displacement in the y direction is 1.5 meters up or negative 1.5 meters down. And that gives, I just plug that in there. I know that the vertical initial velocity in the y direction is 0, so 0 times time plus half acceleration. Since it's being thrown or kicked horizontally, gravity pulls it down, so that we use the gravitational acceleration, which is negative 9.8 meters per second squared up, times time squared. So negative 1.5 equals negative 4.9 times time squared. Divide negative 1.5 by negative 4.9, and you get 0.306. So time equals root of 0.306, and you get time as 0.5532 seconds. So now that you have the time that it takes to hit the ground, you know the displacement in the x direction for the moving object. So I could just do velocity. Since it's being kicked in the x direction, that means the velocity or the speed is, the initial speed is going to be in the x direction. So velocity, or since it wants speed actually, just calculating the speed, I'm just going to do speed equals distance over time. We have the displacement, which can also be written as the distance in this case because it's going 8.3 meters. So I'm just going to rewrite this as distance. So that's going to be 8.3 meters. We have the time, so we can just solve for the speed, 8.3 divided by 0.5532. And we get 15.00 meters per second as the speed. Alright, so let's move on to question number 2. So in this question, we're given that the velocity of a projectile is 1.1 times 10 to the power 3 meters per second at 45 degrees above the horizontal, and that the launch level is the same level as the landing level. Calculate how long the object is airborne. So if we were to draw a diagram, since the object is being thrown from the launch level, let's say the object is being thrown from the ground as the launch level, it goes up and then it comes right back down to the same position. So we're given the velocity on an angle. So let's say this angle is 45 degrees. to do this question, we're going to have to break this up into its x and y components. So to find time, we have the y component acceleration, and we're given the actual velocity, but we need to break this up into the y component velocity to find the time. So to do that, Vy is going to equal 1.1 times 10 to the power 3 times sine 45, because sine is opposite over hypotenuse, and since we want this, we have to use sine. So that is 777.817 meters per second up. Gotta find time. Displacement. The displacement is going to be 0, the initial displacement, because since it's starting originally at this point, it goes up and then it comes back down to the same level that it started from. That means the displacement is just going to be 0. So displacement equals Viy times time plus half acceleration times time squared. We know displacement in the y direction is 0. We have the velocity in the y component. Time, we have acceleration as negative 9.8 times time squared. 0 equals negative 4.9 times squared plus 777.817 time. Now this ends up being a quadratic equation, so you could either use the quadratic formula or you could just factor out the t variable. So I'm just going to go ahead and factor out t, and negative 4.9, so negative 4.9 t times t minus 158.73. So I can just set this equal to 0. So time equals 158.73 seconds, which is approximately 160 seconds. So that's the time. And now part B is asking to find the maximum range. So range is basically the displacement in the x component or x direction. So horizontally, we can find the velocity in the x direction. So velocity in x direction is just going to be 1.1 times 10 to the power 3 meters per second times cos 45, because cos is adjacent over hypotenuse. So if you do that, times cos 45, and we get 777.817 meters per second to the right. We knew that the time was 158 seconds, so displacement is Vix times time. I just rearranged Vix in terms of displacement, the Vix formula, because originally velocity is displacement over time, so I rearranged it to find displacement, x direction, and 7.817 times 158.73, and we end up getting 123,469 meters, or which is pretty close to 1.20 times 10 to the power 2 kilometers. That's pretty close to what it is. It's just rounding it off. I'm just rounding it off to this. So this is the actual answer, but like I'm just rounding it off to 1.2 times 10 to the power 2 kilometers. So that's how I do part B. And now part C is asking to find the maximum height. So in the maximum height, you know that the velocity final is going to be 0 meters per second, because it's temporarily at rest when it's at the maximum position. So we have Viy, which was 777.817 meters per second up. We have acceleration, which is negative 9.8 meters per second squared up, which is basically 9.8 meters per second squared down. And now we're told to find the maximum height. So we can just use this formula. We can just use Vf squared equals Vi squared plus 2AD. Vf squared is 0. Vi squared is 777.817 squared plus 2 times negative 9.8 times displacement. 77.817 squared. We move this square to the other side, so we get negative 604,999.2855 divided by negative 19.6. And that gives us our displacement, or our maximum height, of 30,867.31 meters, which is basically like 30 kilometers up as the maximum height.